Applications frequently need access to sensitive data, such as database credentials, API keys, passwords, and tokens. Of course, we can't just store these secrets in plain text or hard-code it into our applications. Rather, we need to securely protect this sensitive information to ensure that only those with a need-to-know basis can access it. In this episode of Mobycast, Jon and Chris kick off a two-part series on handling secrets for your cloud-native applications. We discuss various approaches to secrets management, ranging from basic roll-your-own techniques to fully managed solutions. We explore some of the most popular options out there and help you decide which one is best for you. Welcome to Mobycast, a show about the techniques and technologies used by the best cloud-native software teams. Each week, your hosts Jon Christensen and Chris Hickman pick a software concept and dive deep to figure it out.
Welcome, Chris. It's another episode of Mobycast.
Hey, Jon. It's good to be back.
Yeah, good to have you back. Happy New Year to everybody listening. This episode. We're recording it just before New Year's, but we know this episode is going to drop on New Year's Day. So happy 2020.
Yeah, where did 2019 go?
Whew. Things are going pretty fast in Mobycast land. We don't know how your New Year's Eve was, Chris, but did you have any plans that were going to make you feel tired today?
So we have a family tradition now. We used to go ice skating on New Year's Eve, and we've kind of since changed that after we kind of realized that the ice skating at the fake rink at the shopping mall was the skates are so painful. So we've switched. Yeah. So it's now bowling on New Year's Eve, and which we kind of discovered it's a heck of a lot of fun. So we do the bowling thing. And then we have a favorite movie that we watched. It's 3.5 hours long. It's called Mad World. And it's like a total encore cast of everyone, just the biggest comedians' names of the 50s and 60s.
Huh, interesting.
And just a really fun movie. So we watch that once a year, New Year's Eve, 3.5 hours, which lasts us right around until midnight. We stay awake till midnight, and then it's beddy bye.
Right on. Wow, that was really interesting. I did not know you had those traditions. I thought you were going to say something like, oh yeah, bed early, probably be going to bed early, that kind of thing, which is, unfortunately, I think that is my story for this year. Traditionally, I like to go see live music on New Year's Eve, but I just didn't get around to getting some tickets to a show. Nothing happening in Denver or up here in the mountains really caught my attention. I've often gone to see the String Cheese Incident, which is a kind of jammy bluegrassy band, but I've done it enough times that I just didn't need to this year. So who knows? Maybe I'll be watching Mad World.
It's like I said, it's a good one. It's a lot of just cool classic lines in it. Like I said, just a great Jonathan Winters and Spencer Tracy and Peter Falk, and there's just so many folks in that. Mr. Howell from Gilligan's Island. So
nice.
Yeah, that's great. And then on New Year's Day, the tradition continues with making homemade bolognese sauce.
Oh, yum.
Yeah, so it takes like 4 hours to cook, but it's so good. So
we'll be over.
Yeah,
hop on a plane. Come have some of that.
It's only 2.5 hours.
Yeah. All right, Chris, let's talk about software. So today we're going to talk about secrets, and we're going to talk about how to manage those secrets so that only your app can see them. Do you want to kick us off?
Sure. So secrets, sensitive data, this is something that our apps typically almost always have a need for, right? Whether it be a connection string to connect to a database, API key, credentials for talking to upstream dependencies or whatnot. So it's just, in general, just about any kind of application will have this need. So they're secrets, right? They're sensitive data, and we don't want to just store those secrets in plain text. We certainly don't want them hard-coded. We've all seen the big faux pas of someone accidentally committing something to Git and then it's like, okay, that's now gone forever. We need to rotate that credential because it was accidentally committed to source control. So we need to have a good, proper way of handling these things. Right.
And Chris, I wanted to also add, I mean, just for people listening, if you were developing software in the late aughts, early teens, things have changed in terms of how you're supposed to handle secrets. So this is an important episode for you if you're doing things that sort of style, which tended to use a lot of environment variables. And then I guess the other thing is maybe you're listening and you have a startup and you went really fast and just built a bunch of software super fast, not thinking so much about security, and it's time to do things right. And you're kind of looking around for best practices. This episode is for you too, or just anybody else that wants to know how to do this right in a repeatable way. That once you set it up once, all your apps can use the same way, and it's not a lot of overhead. So, okay, let's keep going.
Yeah, absolutely. And so there are so we kind of agree. We have sensitive data. We really do need to be responsible on how we protect that. We don't want it in plain text. But there's lots of different techniques, right, for dealing with this, ranging from really simple, roll your own, to more advanced solutions. And so we'll talk a little bit about that. You mentioned environment variables. That has definitely been a tried and true way of dealing with secrets. Part of the variation in there becomes like how those environment variables are declared and when, and that kind of gives rise to what is the surface area of exposure for those secrets as well. There are potentially some issues with environment variables with containers.
Yes,
just by virtue of the way that how containers are implemented. We talked a bit about this on the VMs versus containers mini-series. In general, though, we don't. It's not a huge issue, right? Because in order to really, at the end of the day, with containers, environment variables do end up. You can see them as a file on the actual disk of the host, but you're going to need root access in order to see that. So it's potentially a leak, and you'll hear about environment variables as potentially being leaky, but there's some pretty severe constraints on that. So in general, the consensus is that you can use environment variables for your secrets with containers. You just need to do it in a measured way.
Cool.
Yeah. So, I mean, just, kind of maybe going forward a little bit with just secrets. So, we definitely want to have some comprehensive secrets management solution. We want to think it through and think about, like, we need to support different access patterns across container environments. So, you may have different environments out there. You may have like a dev or staging, and then you have your prod, right? And so you want to be able to deal with those kinds of access patterns. You want to make sure that you do have isolated access to secrets so that it's done on a per container basis or per application basis and not at the host level, right? So you want to limit the surface area, like in that principle of least privilege. So these are all things we want to think about as we come up with, like, well, okay, how are we going to deal with secrets, and what's our management solution to that?
Right. And it goes even deeper than that. I was just working on a proposal for a company that we would be building them some software, and the software we used would be using some secret, would need some access to secrets. But essentially the team wanted to be able to keep those to themselves and not give, another team the access to the secrets. So they came up with a fairly clever way to give us access to something that wouldn't reveal the secrets, but essentially give us the means of getting a pointer to them so that we could pass that pointer on and say, hey, this is the thing that is going to turn into the secret at runtime. Mm-hmm. So yeah, there's all kinds of, it's such a big thing. Like, can everybody see them in terms of people? And then can everybody see them in terms of systems? And the answer to both should be generally no. Unless you have a small team, then sure. Yeah, probably everybody can see them. And then, definitely in terms of systems, it's better if not all the systems can see all the secrets all the time. Just too much surface area.
Yeah. Yeah. Again, principle of least privilege definitely applies here.
Exactly.
Yeah. So some other guidelines we should be thinking about as we put together our secrets management solution is, we talked about like plain text, not a good thing, right? So we want to encrypt the secrets. So when they're stored, they're encrypted. We also want to think about using multiple encryption keys so that we can limit the blast radius as well in case an encryption key is compromised somehow. It's just, I mean, it's a bit of extra credit, but it's not too hard to do. So why not do it? So, consider having definitely probably like on a per application basis, right? Different encryption keys.
So you're saying, just to make sure I understand, a single secret is encrypted multiple times with different keys and stored someplace, and then you get to pick your key when you want it, and any of those keys will work?
No, just think of it as you could have an encryption key like on a per application basis, right?
Okay.
And maybe it's a per application / per environment basis, right? So you have an encryption key for your login service in dev, and you have.
Did you understand what I meant when my confusion? It's not like, did what I said make sense?
Yeah, I think you were thinking that it was, hey, we're going to encrypt a value n times for n different consumers. And each one of those encryptions will be done with their own personal encryption key.
Yeah, that,
right.
Or even we're just going to do it n times because we can. And then we can switch keys with we can kill any of those keys. And then, the other key, the encrypted data is already sitting there ready to go with another key.
Yeah, I mean, so that kind of gets into a little bit, like, I think the use case around something like that is like access control and monitoring and auditing. And so we'll get into that more as in the actual talking, like, what's the implementation landscape look like and the various tools and services you can use. And there's other ways to get those kinds of benefits as well. But I think just in general, on principle, so we want to encrypt, and then when we encrypt, think about having more than one. Don't just have one key for your entire organization, right? Like have
right.
multiple keys, right? So that if there is some sort of breach, or if you do need to revoke that, then the scope is limited to what it affects, right?
So how are we doing on the blast radius drinking games? I think every time we say blast radius, people have to take a drink.
So it's blast radius, and then definitely undifferentiated heavy lifting.
Yeah,
and I think maybe the acceleration rate of technology is changing rapidly, right? Like those three things, and then of course, why not just drink if we say virtualization or container? But
there we go.
Yeah. Some other things, just think about rotating your secrets often, right? So this one is kind of interesting because here you can make a distinction between passwords and secrets. So for user passwords, which we're not really talking about here, right? We're talking about this is more for like services and applications that they're using. But just maybe as a kind of a side point is that, we have these policies where, like, people will, change your password like every 30 days or something like that. And when the user has to pick the password, they've kind of shown that actually ends up being less secure by having them change their password frequently, because they end up choosing really bad passwords. Mm-hmm. So instead you want to pick something that's just, if you pick a really strong password, then the only reason to change it would be if it's compromised or you suspect it to be compromised. But with secrets in general, if you are generating the secrets automatically using high quality techniques, right, for making sure that you have a very strong secret, then rotation of that makes a lot of sense, right? And that's what we're talking about here. So
yeah, but where that's difficult, Chris, is like API keys and other things that you get from third parties. They may have an API for getting a new secret from them, but maybe not. Yeah,
I mean, so you do what you can, right? So if you have the ability to rotate, then do it. If you don't have if you don't really have an ability to rotate, then, I mean, your hands are going to be a little bit tied there. But you probably, looking into it, you'll probably find like there are, especially for the more sensitive secrets. I mean, in general, API keys, they really shouldn't be used for authentication. it really should just be, there should be something else in there as well that's helping out with it, like for a really robust system. But then you have like things like database credentials, right? I mean, that's a pretty sensitive secret, and something like that should definitely be rotated, and you should have the ability to do that with whatever system you're using.
Cool, yeah.
And then, just some other guidelines. How
often is often? Does it kind of depend on how big your team is? Like, and how, like, the sort of target size of your company. So you might have a small team, but you're working on health records. So maybe you should do it once a quarter. Or you might have a small team and you're doing fruit quality. You have a fruit quality app. And not that secret of stuff. So maybe you don't rotate that often at all. So
I think just a couple points there would be like, one, that rotation of the secrets should be automated, right? So it shouldn't be like this manual. If it's a manual process, then that's probably a big problem. So you should be from the get-go thinking about, okay, like what does the automated solution look like? And so then once you have that in place, the frequency ends up becoming almost like, it doesn't really matter. You just pick something that, it really doesn't matter at that point. So pick every 30 days, right? Or every week or every 2 weeks, once you have that automated system in place for doing that rotation. It ends up being like, what is the window of vulnerability, right? Is how often you rotate. So if you're rotating once a year and it's some sort of sensitive data key for API access, right? If you're only rotating that once a year and it gets compromised, and if you don't have the auditing in place to even know that it's been compromised, well, then it's going to be a year until it gets rotated, right? So rotating more often that's one of the big reasons for doing that. And again, if you have like the process in place and if you have put in the automation for this, then rotating more frequently should be just fine. There are systems that essentially rotate like every second, like literally like thousands of times a day type thing. Right?
I want no more than 1 second worth of potentially fraudulent fruit quality data.
Yeah, exactly. Yeah. So I say, just really think it through. Like, okay, how am I going to do my secrets generation, and then the rotation, and then what automation can I put behind that so that I don't make this a manual process? Because if it's a manual process, you're just not going to do it, especially if it's more than a handful of things, right?
Yep. Well, and there's so many things here, and setting up an app the right way, and thinking about things like automatic secret rotation. It can be hard, especially with a greenfield project or a startup, to say, we're going to start in on this, and we're going to have, just kind of getting to a login screen that does something, because we put all of the non-functional requirements up front. It's going to take us 6 weeks. Like, that would be really hard for most business people to handle. So some of this stuff has to get rolled in over time, depending on the type of company that you have.
Yeah, absolutely. And I mean, it's all about, like, you don't have to do everything all at once, right? But at least you should know what it is that you should be doing, and you should plan for that, right? And just know that you need to do it, right? Yeah. Like, don't get 2 years down the road and then find out, like, oh yeah, like, we have like secrets are just distributed throughout the entire system. They're using some proprietary hashing algorithm and hard coded into config files or something like that. And it's going to take us weeks and weeks and weeks, right?
Yeah, solving that problem is way more expensive than doing what we're about to explain. Yeah. Or doing what we're talking about in these episodes here.
Mm-hmm. Yeah, so I mean, you could just say, okay, I don't have time to do it right now. We're just starting off with a project, but at the very least, we can have like a proxy API for we know we're going to have centralized secret management, right? So we'll just kind of basically mock it out, stub it out with some placeholders, and that's just how we do the secrets to start off with, and it gives you that path, right, to go forward.
Yeah.
So that's okay. So we talked about secrets. We talked about like, okay, what are some of the responsible ways of doing this, and then some of the key characteristics of a solution. Thought it'd be kind of interesting to first talk about like, well, let's like given that we've just talked about this and what we'd like to have, what if we talk about just a really simple method? Like if we wanted to roll our own, because there's a lot of really good solutions out there that are managed, that you can just wire up and start using, and definitely we'll be talking about those, but I thought it'd be kind of interesting to first talk about, like, well, what if we just kind of rolled our own? Like, what are, given some of these characteristics, how we go about doing that?
Cool.
And this is all based upon something that we've done in the past before these other systems were available. And we can kind of talk through and reason, like, okay, like, how secure is this? How, does this, what requirements does this meet that we've talked about? And then also, like, what's the potential attack surface that we have to protect, and what happens if what's the mediation if there is a breach? Mm-hmm. So given that, let's talk about a simple method, and we're just going to use basically encryption, decryption, and some place to store. So because we're big fans of AWS, right, and we use it, we're going to use S3 for storage.
Yep.
And we're going to use KMS for encryption and decryption, right? And so this ends up being a really straightforward, simple way of handling secrets. And what we'll do is whatever our secret is, we'll use KMS to encrypt it. That gives us the output of that is some ciphertext. And that ciphertext can then be stored in an S3 key.
Cool.
Right? So we have some bucket somewhere, and we can have keys, and we can partition our namespace there with prefixes to break it out, like, on a per environment basis. So we have, dev, stage, prod buckets, pass, part of the prefix,
right,
underneath their bucket. And then, for each application, maybe there's another that we have, that's part of the prefix. And then finally the key itself, right, where that is the actual ciphertext. So what we're storing on S3 is ciphertext, right? It has been encrypted using KMS. And so if anyone were able to read that file, right, it would just be gibberish.
Right. And the amount of effort to do that is, like, you got to make an S3 client, you got to make a KMS client, you've got to get a key from KMS, and then take your text that you're going to put in S3 and encrypt it. So that's just a couple API calls that you've made so far. Mm-hmm. And then once you encrypt it, you make another API call to put your object into S3. So total of like 4 API calls. And then, of course, the error handling around each of those API calls. Mm-hmm. So not too bad.
No, not at all. In fact, it's basically ends up, you can do it in Bash in about 6 lines of code type thing, right? Or, from the command line, you can do it.
So in Bash, you'd be using the CLI to do it?
Mm-hmm. Yep.
Okay, cool.
Yeah, you bet. So we have our secret. It's encrypted, stored as ciphertext in S3. And then so now, whenever anything needs to access the secret, right, it's going to retrieve that ciphertext from S3. So it's going to be doing an S3 read, get item. And then once it gets that, then it can it can use KMS to now decrypt that ciphertext to recover the secret. Mm-hmm. All right, so again, really pretty simple, but we're using KMS for that strong encryption, for that symmetric encryption, which we talked all about in our encryption mini-series back in episodes 80. What was it? 80? Wow, it was 73 through 76.
Okay, wow, you must have that window open because
yeah, I had to go through the RAM database in my brain. But had to do some page invalidations to make room for it.
So that's all pretty straightforward, Chris. But when it doesn't work the first time, it's going to be because you didn't have the right roles available for whatever the code is that's doing the encryption or decryption. So you got to make sure that there are roles in place that give that code access, allow it to get access to S3, the bucket that you have, and allow it to get access to the key that you need. So some roles have to be set up for this to work too.
Yeah, and that's actually that's one of the strong advantages of this technique, right? Because this does give us a couple of different vectors for really locking this stuff down. So so there's really 2 resources here, right? One is S3, and one is the KMS, the CMK, so the customer master key that we're going to use for encrypting and decrypting.
Yes.
And so we can have policies on the S3 bucket key to lock that down with IAM on which roles or users are able to even read that information,
right?
Or store and read and write that, right? So you can lock that down. We can also use things like VPC endpoints to restrict access to come from within the VPC itself. So if the traffic isn't originated from inside the VPC, then it's denied. So we can really lock S3 down and just
you can make per environment, per application roles. So,
so we have that capability of just being able to read and write ciphertext. We can lock it down, and then of course, ciphertext, you can't really do anything with that, right? You need to be able to decrypt it, and so to decrypt it, you need to have access to the CMK, the customer master key that was used within KMS for encrypting it. And so again, that's another IAM policy. And so specifying users' roles that have permissions to do that, and then you can further lock it down by what the actual keys are. So if you have multiple keys, right, multiple customer master keys, like we said, hey, you shouldn't have just a single key for encryption of your secrets. You should limit that blast radius and have multiple.
Drink.
So you may have a key per. You may.
Sorry about that, everybody. I was just came out. That's what you do when you're playing a drinking game, is you say drink, but we're not actually advocating any kind of drinking to Mobycast.
Well, and it's New Year's Eve, right? So
right,
there you go. So slam your crystal. Yeah, so we have the ability to just really lock it down on the KMS side as well with IAM policies. So two vectors here to really control access to these secrets. And if we just spend a little bit of time getting those policies set up correctly and just thinking through who needs access to it, we have a pretty secure solution, right? And then if we do need to revoke or an application doesn't need access to it anymore, then that's just updating the policies, the IAM policies. So this has been a technique we've used in the past. It's worked really, really well. Again, it's simple. And it does tick off some of the key guidelines or requirements that we need for securely storing our secrets and using our secrets. But it's not full featured either, right? So there's nothing here with, support for automatic rotation of secrets. How do you do that?
Right.
This is using KMS directly for the encryption decryption. So that means we're going to be limited to 4K in size for secrets, which probably is not going to be a problem for you, but it might.
Right.
So
one thing that goes unsaid that's good about this and good about all of the secrets management options that we're advocating for is that if you just get the if you kind of get the secret as part of your code initialization, so it starts up and at runtime it goes and gets the key out of S3 gets the secret out of S3 and decrypts it with the key. That's all just in memory, and as long as you don't write it anywhere to any kind of file, you just have your secret in memory, and it is only in there for as long as your application is alive. And then when your application goes to bed or gets shut off, the secret is not anywhere. It's just very temporal.
Yeah, absolutely. So, it's a great point. This type of technique, you don't have to use things like environment variables. So, as part of that application startup, it can go issue these API calls. As you said, have it. It's just in memory. So it's never written to disk. It's never exposed as an environment variable, and it's very isolated, which is a very good thing. And so that's kind of that additional control that you have by doing this roll your own technique.
Yes. And it's kind of the point. It's the point of all of these techniques is how can we get the secret to be as briefly briefly anywhere, just have it available when you need it kind of thing without, doing anything to substantially slow down your application.
Yep, absolutely.
We cover a lot of information here on Mobycast, and if you've ever wanted to go back and remind yourself of something we talked about in a previous episode, it can be hard to search through our website and transcripts to find exactly what you're looking for. Well, now it's a lot easier. All you have to do is go to mobycast.fm/show-notes and sign up. We'll send you our weekly, super detailed outline that we use to actually record the show. A lot of times, this outline contains more information than we get to during our hour on the air. So sign up and get weekly Mobycast cheat sheets to all of our episodes delivered right to your inbox.
So that's a roll your own technique, if you will. Just kind of wanted to walk through that as just again for completeness, to kind of illustrate like just the full gamut of like what your options are. As we mentioned, there are full up systems out there for just dealing with secrets management.
Yes,
and there's some good ones, and you really should be looking long and hard at these, because they give you they deal with a lot of the undifferentiated heavy lifting, right? That you don't have to do. So, why reinvent the wheel? Especially if you don't need like that full customization and control over the solution. And so in general, secrets management tools, like some of the features that you really want to think about when you consider these are like, obviously, they should allow you to securely store and tightly control access to your secrets. You want to think about protecting the data both at rest and in transit.
Yep.
You want this to be centrally managed. So you can go to like one place and see all your secrets and know like who's able to access it. And, ideally you be able to see things like version history, for like when secrets are changed and whatnot. So having that central management is important.
Yes.
You obviously want secure authorization and authentication mechanisms for these secrets.
Right.
And encryption, obviously, and key management integration with those types of providers is important. Auditing, like being able to audit like who's accessing secrets, using secrets, like that would be an important feature. And
yeah, that right there is probably a requirement of certain regulatory agencies. That auditing piece. Yep,
absolutely. And then of course rotation of secrets and revocation as well. All important things to have. So these are definitely some of the things that you should expect from a secrets management tool.
Right, and I can't imagine that there are any commercially successful ones that don't just take care of all of these things for you. So it's not like a list of things to go make sure that they do. They do it. They all do it. It's more like just sort of an awareness of these are all the things these do. And if you're rolling your own, there's probably a few of these things that you aren't doing with your own that you would want to do. And then it's like, well, if you're going to write that, you might as well just buy it.
Yep, absolutely. So given that, let's talk about some of the popular solutions that are out there. So first, thought we'd mention, HashiCorp, they have a product called Vault, and this is very well known, very popular. It's been around for years now, and that's their secrets management system, and it works well for all types of environments. So it works if you're on-prem, if you're hybrid, enterprise, it's going to work well for that. It's also multi-cloud, right? This is one of the great features that HashiCorp has for almost all of its product line, is that they have distinguished themselves by being multi-cloud, by being cloud agnostic.
That's right.
So, but some of the downsides of this is like, it's not managed at all. Like, this is self-hosted. So you have to go spin up the boxes to run the software, to run Vault on it, right? So, and then you have the licensing fees as well for the software itself. So you have to, you're paying for the machines to run it on, the licensing fees. And so if you are not like a big company, or you have lots of secrets to manage, then it can be really kind of expensive, and also not just from a pure cost standpoint, but just from a human standpoint of like how much overhead it is to learn this, spin it up, to maintain it, manage it, all that kind of stuff, right? So that's one of the downsides to something like that.
And then just in terms of all the requirements that a secrets manager has to have, from auditing to rotation to revocation, protecting data at rest and in transit, unfortunately, HashiCorp Vault does not protect data in transit. Just kidding. Of course it does. They all do. They all do all of these things. I was just making sure everybody was listening.
So I was like, oh man, how am I gonna listen? It's like, John, did you fall and hit your head?
It is wild to me though that you say it can be expensive because it's not managed, and it's like, wow, that's the hard part of any of this, managing this stuff. Like, why would it be expensive if you're not going to manage it for me? Pretty wild. I mean, maybe part of what you're saying is like the management of your own boxes.
Yeah, I'm so the total cost, right? So you have you're gonna pay to spin up instances, right? So so there's that. So let's just say you run on EC2, or maybe you have to go buy a one-use server from Dell or whatever, right? Like, you've got to have the hardware to run it on. So there's that cost. Then you have the cost that you pay to Hashi for the licensing fees of the software itself. And then you have the cost of just what it takes to run this from just like a maintenance and management standpoint, right? So there's three vectors there of cost. Versus a managed solution, really it's just like, okay, what's the pricing structure? And that's what I pay, right?
Yeah.
So that's Vault. Just again, wanted to kind of like throw that out there as like, this is one of the older kids on the block. It's very established. It's popular. Whenever you talk about secrets management, you're going to hear about Vault. So just wanted to talk about that for completeness.
Cool.
So moving on to AWS and managed solutions, and AWS offers two. So we have Systems Manager Parameter Store. Favorite
name. Love that name.
Yes. And then we have AWS Secrets Manager, which is a standalone service that is really hyper-focused on just dealing with secrets. So two different services to use. Pros and cons to each. So I thought maybe we just kind of go through and just talk about each one of these first, what they are and their characteristics. And then because they are so similar and there is a bit of confusion of like, well, which one should I use? We'll go into like, let's compare these two, right? And try to tease that out and understand like, what are the similarities? What are the key differences? And what are the reasons you would choose one versus the other? So given that, let's talk a little bit about Systems Manager Parameter Store. And so what this is a managed, so Systems Manager is a huge offering, right? And it has, there's at least 10 or 11 subservices underneath Systems Manager, right? So there's things like Patch Manager, there's Session Manager, there's the Run command, there's just so many pieces to it. And so Parameter Store is one of those subservices underneath Systems Manager. And so that it's a service that allows you to store key value pairs, and the values can either be unencrypted, so plain text, or they can be encrypted.
Okay.
And so some flexibility there, right? So it's not just for secrets, right? It's basically for just any kind of key value pairs you want to store in a managed service, is what Parameter Store is giving you. And it does, so as far as the encrypted values that it supports, there's two tiers of support it has there. So one is standard, and then the other is advanced. And so the difference between these two is with standard, and so both of these, it's going to be using KMS for encryption.
Okay.
With standard, you're going to be limited to a maximum of 4K bytes on your values.
Okay.
And the reason for this is because with the standard secure string parameters, it's going to do encryption and decryption directly using KMS with the CMK that you specify.
Right.
Okay. So KMS, it has the limitation, right? It will encrypt up to 4K bytes chunks, right? You can't send it any more than that. KMS, right? That's just the limit there. So that's why
it feels like Systems Manager Parameter Store with standard encryption is downright similar to what we already described in terms of a roll your own solution.
It's really similar because, who
knows what they use under the hood.
Underneath the covers, they're probably using, I would think they're using something like Dynamo for the store, but you never know.
Could be S3 too, right?
Yeah.
Like S3 has, huge reliability and data, data retention and data trustworthiness.
11 nines.
Yep.
Yeah. So that's standard. So, you can use that as long as your values are going to be less than 4K. And then at the advanced tier, what that is any guesses what advanced is?
No, I'm sorry. Unfortunately, I'm just waking up here.
So with advanced, it's just if you have more than 4K bytes, right? It supports more than 4K bytes.
Oh, I thought you were going to say, I thought you were asking me, how it was implemented. Like whether it was just, also, I was thinking, standard uses KMS, uses the direct encrypt decrypt. So how does advanced work? I actually don't know. Maybe they line up a bunch of KMSs and end like a linked list. I have no idea.
Yeah. No, it's just kind of interesting. You can see how this, I don't know what the history is for parameter store.
I see what you're getting at.
I kind of imagine, they probably came out of the gate where they're like,
customer focus. Yes.
Well, they just
we need more than 4K. Okay. We give you advanced.
Yeah, exactly.
We hereby introduce advanced.
Yeah. And we call it advanced, right? So I bet that's kind of how it evolved. I wouldn't be surprised.
You're going to pay more for advanced.
Yeah. So that's what advanced is. Advanced is just it supports more than 4K bytes. And it does that by using envelope encryption. Hopefully we remember what envelope encryption is. That was back again in those encryption episodes, the 4-part miniseries. So if folks haven't listened to those, I would strongly encourage you to go back and to listen to some of those, especially episode 76, which was kind of a dive into the AWS encryption techniques and really kind of a deep dive into KMS. And so we talk a lot there about just what envelope encryption is. But just as a quick rehash, envelope encryption is you use KMS and your customer master key to generate a data key. So this is a new AES 256 encryption, symmetric encryption key that KMS gives you. And then you now do the decryption outside of KMS, and you can do whatever, and now you can do whatever size you want, right? So if you have a megabyte that you want to encrypt, right, you go ahead and do that because you're doing it outside of KMS. And then once you produce that ciphertext, you then have the data key that was used to encrypt it. You then encrypt the data key and you store it alongside the encrypted secret, right? So that's the envelope. So you can think of, inside the envelope is the encrypted data, and then on the outside of the envelope, or however you want to think of it, that's the encrypted data key. And so in order to decrypt the value, you first have to have access to the customer master key to decrypt the data key. And then once you decrypt the data key, now you can decrypt, and you're decrypting the data key using KMS. Once you've got the unencrypted data key, you can now use that to decrypt the secret ciphertext outside of KMS. Right. So that's
one thing that just on all of that I like to repeat that's sort of easy for me to remember is just that the handshake style encryption that uses public keys. So asymmetric encryption is slow and uses a lot of math. And the symmetric encryption that uses these data keys, the AES style encryption, is fast and uses a lot of very fast operations, moving bits around XOR type operations inside a chip. So you can do lots and lots of it really, really fast.
Yeah. So that's why we use asymmetric encryption for sharing of secrets, because that's a good way to share secrets. It's secure when you don't have a trusted intermediary.
Yes.
And then once you've exchanged the shared secret, then you switch over to the symmetric for the bulk of your encryption decryption, and you can do it very, very efficiently.
Cool.
And that's how things like TLS work. So again, if all that's new to you, go back to the encryption mini series, and pretty fascinating information. So that is
all right.
So that's parameter store. Yeah. So
Systems Manager Parameter Store. Advanced. Now we know it's not a linked list of KMS master key decryption. It could have been, but they instead used envelope encryption.
Yep, indeed. Could you imagine? I mean, you could do that, right? Like you could actually you would just splice it up into 4K chunks and encrypt, and then when you wanted to go read it, you'd have to keep track.
You put me on the
which
spot
ones.
in the interview, and that's what came to my mind, right?
Yeah.
I did not get the job at Google today.
Well, it's a new year. You never know, right? So that's the great thing about New Year's, is full of hope and opportunity. So,
Yes.
So don't give up. So let's talk about the other one, Secrets Manager. And so Secrets Manager is fairly newish. It was first released in April of 2018. So a little over 18 months old now. And so this is a service that it encrypts and stores secrets only. And transparently it decrypts them and returns them to you in plain text when you request them, right? So this, one of the big differences here is that with Secrets Manager, everything is encrypted. You can't store anything unencrypted. And so it's been designed really from the ground up to be dealing purely with secrets and everything that goes around with it. So you can rotate and manage and retrieve sensitive data. It does support periodic rotation of secrets with RDS databases. It's just built right into it. So
cool.
It knows exactly how to rotate secrets with RDS and does that on your behalf. Nice. So the secret values that you're storing in Secrets Manager, they can be any string or binary data up to 10,240 bytes. So quite a bit bigger than the standard tier for parameter store. And so it does this by, it's actually using envelope encryption. So Secrets Manager is using envelope encryption. So again, it's kind of interesting. It creates a data key for every secret value.
Yep.
Okay. So, if you're storing 100 different secrets, using Secrets Manager, then it's going to have 100 different data keys, encryption keys. So, that'll generate on your behalf using that CMK, that customer master key with KMS. Whenever a value changes, then a new data key is generated. So it's not just one per value, it's actually one per value version. Is generated. And so that data key, it's encrypted using the CMK that you specify. And because it's envelope encryption, then that encrypted data key is going to be stored alongside the metadata of the secret. One of the good things here as well is that because it is using KMS and because it's using a CMK, and you specify the CMK for each secret. In fact, you can have so you can be using multiple CMKs here with secrets that you're using with Secret Manager. So again, you could have 100 secrets that you're storing, and maybe the way that you partition them up, you're going to be using like 5 different CMKs across that. Like you totally can do that. You can have one CMK, you can have 5, you can have as many as you want. But because it's using KMS and because it's using a CMK, again, we can control access further through IAM. And we also have the auditing and all the other good stuff that comes along with it. So both Secrets Manager and Parameter Store, we kind of get that benefit of piggybacking on top of KMS and all the goodness that comes from that. Okay. And so maybe just quickly some just overall like the workflows, what's happening with encryption and decryption. And this kind of helps a little bit, I think, with just further reinforcing like that envelope encryption. So when Secrets Manager, when you want to encrypt something, the first thing it's going to do is going to call KMS's generate data key API using the CMK that you specified for that secret. And so KMS will then generate this new 256-bit AES symmetric key, and it's going to return that both as a plain text value as well as the ciphertext version of it. So you're going to get both the encrypted and the unencrypted version of that new data key. And so after that, now that it has a data key, Secrets Manager can then take the data that you gave it, and it's going to use AES 256 to encrypt it using the plaintext data key. And then once it has the ciphertext of your secret, it's now going to store that. And alongside of it, it's going to take that ciphertext version of the data key and put that in the metadata of the secret, right? So that's what encryption looks like. So pretty straightforward, kind of what we talked about. And then decryption is really kind of like the reverse of that. So when you go to decrypt something with Secrets Manager, it's going to go and call KMS's decrypt API operation, and it's going to pass in that encrypted data key that it gets from the metadata of the secret. And so it's going to be using the CMK for that to decrypt it. And so now it has back the plaintext version of the data key. And once it has the plaintext data key, it can now do the decrypt of the ciphertext of the secret value. And that's the decryption operation for Secrets Manager.
I wonder about one thing with both of these managed services. Do they... there's like the spy movie test, like, okay, there's a bomb about to hit the White House and you have 30 seconds to get the secret out of the system. And one of the easiest ways when you only have 30 seconds and you have like the entire chain of command standing around your desk waiting for you to get it done within that 30 seconds is if within the console, like you can kind of click through and get to secrets instead of having to use, things that are hard to memorize, like CLI commands and API commands in order to get to anything. Do they let you get to stuff through the console if you have the right level of access, or no?
Yeah, so both Parameter Store and Secrets Manager have robust console applications that you can go in and see all, you can see what parameters are being stored, what secrets are being stored. You can...
And I imagine they have like a little, reveal or kind of thing, some sort of UX that says, show me this, and not just like, let me puke all these secrets in plain text out onto the screen, but, reveal one at a time what I need to see with all my bosses behind me in order to save the world.
Yes.
Within 30 seconds.
Yep. Yeah.
Okay, cool.
And so those are the thing, absolutely that you get with like a managed, with a managed system for managing your secrets, is that you want that full robust capability. And like you don't want to have to be relying on like, I have to only do this with the command line, and what's that API command again? And
cool.
And then it's too late. Yeah. All right. Well, I think that is quite a bit for today. I think next time. Yeah,
especially with the hangover. Or I actually don't know if this is coming. We talked at the beginning that this was coming out on New Year's Day, but then you said later in the episode that it was New Year's Eve. And so now I'm confused, and our listeners are obviously not, because they know what day it is today. But I'm confused.
Yes. They should be listening on New Year's Day.
Okay, cool.
Yes.
So with a hangover. So what better medicine, right? Like talking about the details of encrypting and decrypting secrets. Like that is absolutely what you want to hear.
Well, I think you have the hangover because you were playing the drinking game on whenever it's a blast radius. So, yeah.
Right.
Me, I had to follow the agenda here and I watch my men world. So, yeah. All right.
Right on. Thanks so much again, Chris. This is huge.
Yeah.
This is a good episode, and looking forward to talking about it in a bit more detail and getting into how certain things work with actually implementing this next week.
Yeah. So next time we'll go into like, okay, what is the difference between Parameter Store versus Secrets Manager? Like, how do we choose? Because they seem to be so similar. So there's a lot of confusion there. So let's figure that out. And then after that, it's like, okay, we have a containerized app. It's running on ECS. Like, how do we integrate with Secrets Manager or Parameter Store? How easy is it? And just what's the mechanics of that? Like, how do we do that? And so we'll walk through that.
All right. Thanks so much. Catch you next week, Chris.
Great. Thanks, John.
Bye.
Bye.
Thanks for being aboard with us on this week's episode of Mobycast. Also, thanks to our producer, Roy England. And I'm our announcer, Stevie Rose. Come talk to us on mobycast.fm or on Reddit at r/Mobycast.